Welcome to Sundar's lecture. This is lecture number 93, and in this lecture we are going to see some numerical problems related to a star connected system. See, what are the topics we have seen in the previous class? See, we have started with the star connected system, and in star connected system, and we have derived the expression for line and phase currents and also line and phase voltages. In star connected system, the line current and the phase currents are equal. We have seen that those equation, and then we have gone for line and phase voltage differences, right? So what we have concluded finally, we have concluded that the line voltages are root 3 times the phase voltage, and also it leads the phase voltage by 30 degree. Or in other hands, if you say the phase voltages are root 3 times lesser than, maybe divided by root 3 times, and it will lags the line voltage by 30 degree. You can write this expression, maybe this expression may be written as, see, Vp, maybe Vr, that is line phase voltage, can be written as Vry divided by root 3 at an angle of minus 30 degree. Try to understand. You can say in other hand also. That is also possible, right? So we have concluded like this. Maybe the line voltages will be root 3 times phase voltages, and it will leads the phase voltage by 30 degree, right? That is what we have seen. And now we will take some problems, and we have just concluded like this. And see, the star connected 3-phase load, that is R1, whatever the value for R1, here it is resistive load 100 ohms, is connected to a balanced supply voltage of 173.2 voltage 50 hertz. The phase sequence is ABC. See, I have told you what is ABC, if it is BAC, whatever it may be. See, it is ABC, I will explain you further. And then considering phase A voltage as reference, try to understand. They are saying phase A voltage as a reference one, right? So whatever the voltage they have given you in the questions, you have to take it as the line voltages. Try to understand. It has to be line voltages, whatever the values they have given you. Here they have not specified, right? They have just given a balanced supply of 173.2 volt, but you have to assume that it is the line voltages. Unless it is not specified, it is a phase voltage, then you have to consider it to be line voltages, right? Then what they have told, they are asking you to consider the phase A voltage as a reference, and you have to find what is the current in what is the currents, line currents, and then draw the phasor showing line currents and phase voltages, right? And line voltages, right? So what they have given you, see, if the uh, supply voltage is 173.2, then it has to be VAB, that is equal to 173.2 volt. That is what they have given you. See, that is what they have given you. See, the another thing what they are asking you to do, you have to assume a phase A voltage. Maybe I will write it as VA, that is phase A voltage. That will be is equal to, this is line voltage, right? This is line voltage, so this is not exactly VAB, maybe it's not exactly VAB, I have written it as a line voltage, right? So 173.2 divided by root 3, this to be at an angle of 0 degree. Try to understand, this is actually phase voltage, and this line voltage they have given. So line voltage divided by root 3 will give you phase voltage, and we have to take this as now reference voltage, right? Then what will be this value? So VA will be is equal to 100 at an angle of 0 degree. That's all. Now if you know any one phase voltage, what will be the other phase voltages? Very simply you can write, because everything will be 120 degree, right? So it will be VB. I am writing VB. Maybe generally they will write it as VBN, VAN to specify it as the phase voltages. But I just written it as VB, right? So it will be 100 at an angle of minus 120 degree. Why? Because ABC sequence, A comes first, next B, next C. That's all. So then VC can be written as 100 at an angle of minus 240 degree or plus 120 degree. Right? This is how you can write the value of the line voltages. Right? Now we need to find what is the line current. What is line current? If I'm going for IA, then this will be VA divided by whatever the resistance value, it is R1. So what you will get? It will be 100 divided by 10, right? 100 ohms, right? 100 ohms. R1 value is 100 ohms at an angle of 0 degree. And here, because this is resistance, then it will also have 0 degree, right? So what you will get? 1 at an angle of 0 degree. See, if you find one phase current, then you can go for further things, right? It is very simple. It is not necessary to again and again, you don't need to write the expressions. What it will be? 1 at an angle of minus 120 degree. Try to understand, if this is 0 degree, then IB will be minus 120 degree. Then IC will be 1 at an angle of minus 240 degree. That's all. Maybe if you go for 240 degree, or it will be plus 120 degree, anything it may be, right? So now we have found what is the value of line currents. That is what they have asked you. And in star connected system, line voltage will be equal to phase voltages, whatever it may be, right? So we can write simply these three values. Then they are asking you to draw the phasor diagram. Will you draw the phasor diagram? See, uh, reference voltage, this is VA, that is the they are asking for line voltage. Maybe I will go for reference first of all, because we are taking a reference to be like this, and they are telling this is 120 degree apart, that is VB, and this is 120 degree apart, this is VC. See, try to understand, this is VA, this is VB, and this is VC. These are all phase current, phase voltages, right? Then what is the value of the line voltage? It will be 30 degree leading, right? It will be 30 degree leading, or it will come, because line voltage will be higher than the phase voltage. Maybe it will come like this, it will come like this, right? This will be VAB, this will be what? VAB, right? And then if I'm going for this value, this will be what is this value? This will be VBC. And if I'm going for VCA, this will be VCA, right? Every angle, these angles, it will be what now? 30 degree. See, 30 degree it is leading, and then 30 degree it is leading here, 30 degree, and then you see VCA, it is again 30 degree leading. I try to understand things, right? This value, which is nothing but it is 173.2 volt. It is 173.2 volt. What is this value? This is nothing but it is 100. See, it is 0 degree, it is 30 degree, right? Try to understand the difference between the line voltages and phase voltages, right? Then what they are asking you? They are asking you to draw the current value. Current is 1 ampere, right? 1 ampere, and that too, this is a resistive load. So what happens to the line or line currents? It will be same as phase current. So you will get around here. This is nothing but IA. This is nothing but IA, and what is this one? This is nothing but IB, and this is nothing but you will get it as IC, because it is resistive load. Current, line current, and phase current and phase voltages are in the same lane, right? Because there is no difference, right? What is this value? This is nothing but 1 ampere, right? Try to understand. This is the graph, right? We have just got all the answers for this particular question, right? We will go to the next one now. See, this is the second problem, and what is the question they have asked you? In a balanced three-phase circuit, the voltage VAB is 173.2 at an angle of 0 degree volt. Determine all the voltages, phase and line, and then current phase and line for Y connected load having 10 at an angle of 20 degree ohms. Consider the phase sequence ABC. The same thing, right? They have given you here the reference. See, if it is 0 degree, then you have to consider that to be the reference value. See, what is VAB? VAB is the line voltage. Try to understand, right? What they have given you here? They have given you VAB will be is equal to 173.2 at an angle of 0 degree, right? Then if this is VAB, then what will be VBC? VBC will be same value 173.2, because it is a balanced three-phase circuit. Then this value will be what? Minus 120 degree. and what will be VCA? VCA will be is equal to 173.2 and it will be minus 240 degree. Try to understand, right? So this is what they have given you, and they have generally gave this Z1 value. It is 10 at an angle of 20 degree ohms, right? That is a common value because it is a balanced load again, right? All the impedance value will be same in a balanced load, right? So now we have got this one. Now we need to find what is the phase voltages, right? So generally, maybe I will write it as VA. In so many books they have given it as VAN, but I always use VA, right? So what is VA then? See, this always leads. That means this line voltage always leads the phase voltage by 30 degree. You would have known that this one, right? You see here, we have just written here. See, always line voltage leads the phase voltage by 30 degree. Can you understand that one? So that you apply that here. This is 30 degree already leading. Then what is this value now? It is 173.2. Since it is phase voltage, you have to divide this line voltage value by root 3, and this will be leading by 30 degree means from 0, if you less 30 degree, then it will be minus 30 degree. Try to understand. Try to understand very clearly because this is very important. See, this is line voltage divided by root 3. I am getting phase voltage. But this is the reference now. They are not given you phase voltage as a reference. They have given you line voltage as a reference value. So what it will be now? This will come by 30 degree lagging. Try to understand. Then if VB comes here, that is 173.2 divided by root 3 at an angle of, from here you have to put minus 120 degrees. So what you will get? What you will get? It will be minus 150 degree from here, and then if you are going for VC, it will be again 173.2 divided by root 3 at an angle of minus 240 minus 230, right? So minus 30. So what you will get? Minus 270 degree. Try to understand. We have got now line phase voltages, right? Now I need to find what is the line current. How will you find line current? Maybe I will go here. IA will be is equal to VA divided by Z1. What you will get? VA, what is the value of VA? It is 173.2 divided by root 3, it will be 100 at an angle of minus 30 degree divided by 10 at an angle of 20 degree, right? So finally what I will get? What is the value of IA? I will get IA will be is equal to, if I divide this one, this will be 10 times. So 10 at an angle of, if I bring this to the numerator side, it will be minus 50 degree. Try to understand. This is the value of IA, and if I am going for IB, it is very simple now. See, you don't need to again substitute these kind of values to get this value. See, if you get phase current at a single step, if you get what is IA phase current, then you can go for the IB current in a single step. What is this one? The magnitude will be same. From here it is minus 120, so it will be minus 170 degree amperes. And then if you are going for IC, then it will be 10 at an angle of, it is minus 50 is already there, minus 240. From here it is minus 240, minus 290. From here it is minus 120. From here it is minus 120. Try to understand very clearly that, because it is very simple. If you find any one phase current, then you can write the other phase current by minus 120 degree, minus 140, minus 240 degree. Very simply you can write all the values. So we have found all the values, right? That is what we have asked you. Determine all the phase and line voltages. This is phase voltage, this is line voltage, this is phase voltage, this is nothing but the phase current. Maybe in star connection, both the phase current and line currents are equal, right? So we have found all the values. We will go to the next problem. So now you see, this is the problem number 3, and what they have given, for the given 3-phase system, find IA, IB, IC with A phase voltage as the reference and ABC be the phase sequence, right? That is what they have given you. See, what is the line voltage they have given you? See, line voltage, it is 400 volt, but they have given you A phase. Take A phase as a reference voltage. See what I can do now. I take VA, that is phase voltage, and this is line voltage, right? This is line voltage. So what I can do? It is 400 divided by root 3 because it is line voltage, and that I have divided it by 3 root 3, and I have to take this as no reference because they have told you to take A phase voltage as the reference, not line. See, they have not given you line here, they have given you phase, right? So now this is the VA, and what is the Z they have given you? What is the Z? They have given you Z value will be is equal to, all z's are same, try to understand, all z's are same, so it will be 8 minus j10, right? If I convert this into polar form, I am getting it to be 12.81 at an angle of minus 51.34 degree ohms, right? So now I have got this one. So if I know what is VA, then I can go simply, right? If I divide this by root 3, I will get VB is equal to, it is 230.9, I think. So 230.9 at an angle of, see, if this is 0 degree, then what happens? It will be what? Minus 120 degree. And what will be VC? Again, same thing, it is 230.9 at an angle of minus 240 degree, right? Can you understand? I have gone for phase voltages, and if I want to find what is IA, that is phase current, then it will be 230.9, this value at an angle of 0 degree divided by 12.81 at an angle of minus 51.34 degree, right? If I further simplify this, what I will get? So IA will be is equal to, if I divide this magnitude, I am getting it to be 18.03 at an angle of, if I bring this denominator angle to the numerator, it will be 51.34 degree amperes. See, I got line IA, line or phase current, anything it may be, right? Then what will be IB? See, I can again go to here and divide it by this value, bring it to numerator, whatever, I can do that, but I'm not going to do that. Why? Because the magnitude will be same, because it is a balanced circuit. And what will be 51.34 minus 120 degree? Because it will be minus 120 degree, right? From A to B it will be minus 120 degree, and if I simplify this, I will get 68.66 degrees. Simply I can write. See, try to understand, right? Then what is IC now? IC will be is equal to 18.03, and from here it is minus 240 degree, right? So if I am going to 51.34 minus 240, what I will get? I am getting it to be minus 188.66 degree amperes. That's all, right? I have found what is IA, what is IB, what is ICC. In star connection, you have to understand two certain things very clearly. See, phase voltage will lag the line voltage by 30 degree, or line voltage leads the phase voltage by 30 degree. And if you know any one phase current, or any one phase voltage, or any one line voltage, then you get other sequence line voltages or phase voltages by minus 120 degree, minus 240 degree. See why? Because this is coming with, because it is ABC sequence. So A comes first, B comes next, C comes next, and also VAB, VBC, VCA. That's all. If I go for like this, VAB, VBC, VCA, simply I can write this. It is minus 120 degree, it is minus 240 degree. That's all, right? So we have just solved this one. We will go to the another problem. See, this is the next problem, problem number 4. And in the figure, the load is supplied from three-phase balanced voltage source, that is three-phase balanced voltage source, and the phase sequence is ABC. If phase A current is 10 amperes, see this phase A current, they have given it as 10 amperes. Find VBN and VAB. Both they are asking. If it is VBN, it is VB. We are taking it to be VB, and this value it is VAB, which means this is line voltage, sorry, this is phase voltage, and this is nothing but line voltage, right? So what we will do now, we know that it is IA, we know IA value, they have given you IA to be 10 at an angle of 0 degree, 10 at an angle of 0 degree. So they have indirectly said that phase voltage will be the line current, or phase current, we can say it as phase current will be the reference one. So how will you find the uh, uh, phase voltage now? It is VA, which is equal to IA multiplication of this value, because all z's are same. So what you will get? It is 6 minus 8j simply. So what it will be now? So I will get it as 10 at an angle of 0 degree multiplication of 6 minus 8j, right? Can you understand one thing very clearly? This will be now VA. So what is VA? I am getting, if I simplify this, you just multiply these two terms, I am getting it to be 100 at an angle of minus 53.13 voltage. That's all. If I know this value, simply see, if I know this one value, I can easily find these two values. How? Why? How? If I know VA, right? So how will you write VB now? So VB will be is equal to the same value. It will be minus 120 degree, minus, because it is VA. Next it will be VB. So they have given you, it is ABC sequence. So what you will get? This will be 100 at an angle of minus 120 minus 53 point maybe so it will be minus 120 minus 53.13. So what you will get? It will be minus 173.13 degrees, right? This is nothing but it is minus 120 degree apart, right? Because this is VA. VA will be always 120 degree apart, minus 120 degree apart by, sorry, VB will be minus 120 degree apart from VA. And then if I go for VC, they have not asked you VC anyhow. So I'm not going into in very deep into that. If I, even if I write VC, what I will get? 100 at an angle of minus 53.13 minus 240. What I will get? So I am getting the value to be, it is minus 293.13 degree, right? So this is what we see, but they have not asked you VC anyhow. So next, what I am going to do? I am going to find what is VAB. See, try to understand one thing. You know what is VA, right? Maybe I have written it as in capital letters. Try to understand. You don't confuse yourself. See, you know what is VA, right? VAB will leads the VA by 30 degree. We know that in star connected system, and the volt and the magnitude will be multiplied by root 3. So what you will get? 100 will be multiplied by root 3, because this is line voltage, not phase voltage. If it is phase voltage, then we would have divided by root 3. So this will be line voltage. So generally V line voltage will be is equal to root 3 times V phase voltage. Try to understand. And then the angle will be now, this will leads the phase voltage by 30 degree. Try to understand, right? So what I will get now, this is already minus 53.13 degree plus 30 degree, that is the thing you have to understand. So finally what I will get? VAB, if I multiply 100 with root 3, I will get 173.2. You know that very simply. And if I just simplify this, I will get minus 23.13 degrees. See, try to understand certain things, because why I really want to take this much problems to make you understand things. You have to be very clear that line voltages leads the phase voltage by 30 degree. If it is VA, then VAB will leads by 30 degree. Try to understand. Right? This will leads 30 degree lead. And then if it is VB, then VBC leads 30 degree. See, try to understand these kind of small informations you have to understand very clearly, right? So we have solved many problems today. So I will consolidate. So what are all the problems we have seen today? We have taken the first problem here, and you see a simple circuit with a resistive load they have given you, and they have given you the line voltage that we have converted into phase voltage, and they have given you phase as the reference, and then we have found what is the phase voltages, 0 degree, minus 120, minus 240, and then you have divided it with the resistance to get the line currents or phase currents, whatever it may be. I am getting phase currents here, phase currents and line currents are equal, and then we have drawn with the phasor diagrams. And all other problems we followed the same step here. line voltage is given as the reference. So what we have done, we have just taken it to be V phase voltage can be the magnitude divided by root 3, and since it is that 0 degree, then your phase voltage will be lagged, right, by 30 degrees. So I am just taking, I have just taken it as minus 30 degree, and we have solved this problem. And what is the difference in this one? It is very simple. They have given you Z value, and they have given you what is VA, right? What is sorry, they have given you the line voltage, and they have converted into phase voltages, and we have solved this problem. But in this problem, it is little bit different one. They have given you current value as the reference one. See, whatever, they can take anything as a reference value. Here they have taken phase current as the reference value, whatever it may be, phase current or line current, whatever it may be, both are same in the star connected systems, right? So from there I have found what is VA value, and then from VA I have found what is VB, what is VC. From VA I can easily find what is the value of VAB. Try to understand these kind of things, and we will go for delta connected system in the next class, right? Until then, you just try to go through these topics. We will see in the next class with the delta connected systems. Thank you.